All right, so we have a problem over here where we're given that we have a random variable x that is distributed binomially with 40 trials and a probability of success of 0.58. That's what this notation means. It's telling me everything I need to know about the probability distribution of my random variable. And then it's going to have me find some probabilities of specific values down here. So I'm going to go over here to Desmos. And the first thing I need to do is let Desmos know about my binomial random variable. So I can either type the function binomial dist, and notice right now it's sort of giving me an error, like it doesn't know what I'm asking it to do. But when I put a parenthesis, because this is a function, so a function needs parentheses in order to take inputs, it tells me exactly what inputs it needs. It needs the number of trials, which here is 40, and the success probability, which means the probability of success on a single trial. Now that's everything that I need to define my distribution. And notice now that I did that, a couple of things happen. First of all, it gives me this drop down, which I'm going to use in a minute to find probabilities. It also shows me this little zoom fit icon, which lets me, if I want to, see the plot of this binomial distribution. And clicking on any point gives me that single probability. The probability in this distribution that x equals 31 is 0.005157. That's what those points mean, but I don't really need those, so you can kind of just ignore that. So let's go over here to the problem. The first probability I want is the probability that x is equal to 20. So when I drop down this cumulative probability, it shows me, first of all, it puts some default numbers in here, and it shows me over here on my graph what area in my probability distribution it's giving me a probability of. So I have it set right now. The default region is inner, and inner is what I want for a single probability value. So what I'm going to do to find the probability of the exact outcome, x equals 20 successes out of 40 trials, is I'm just going to put in 20 as both my lower and upper bound. And so that gives me, when I put those boundaries in, it gives me the probability here. Again, I can also see it on the graph. And if I click on that point on the graph, I can see that probability value to more decimal places. I can also click on this drop down where it's giving me the probability, because I want my probabilities over here to be to 4 decimal places. So by clicking there, I see my probability to more than the given decimal places up above. So that's going to be my answer to 4 decimal places. Remember that you can submit a part at a time. So I've done that, and I can see that I got that part right. Okay, so now I want the next probability. Now there's a couple of things to keep in mind. I could just change values up here where I've already defined my binomial distribution. But if I do that, I lose that part of my work. So here's a way to make a copy of this line of the graph. Go up here to the gear that says Edit List. And when I click on that, now it's giving me a duplicate icon. So I could duplicate this once, or I could go ahead and duplicate it 3 times, since I've got 4 parts over here. So now all of the work for this whole problem will be in this graph if I'm going to share the graph later for supporting work. All right, so let me go to my second line of my binomial dist. My distribution is the same. I'm not changing anything in the definition of my distribution, but now I need the probability x is less than or equal to 16. So a less than probability, less than or equal to, means that, let me turn off this graph. Less than or equal to probability means I want the left region of my binomial distribution, because it's less than or equal to some value. So here it's x less than or equal to 16. So I'm going to change my upper limit to 16. Again, you can see that this shades in, it fills in the circles in my distribution for all of the values that are included in this probability. The probability that x is less than or equal to 16 means the probability that x equals 16 or x equals 15, so on and so on. So that's how it's computing that probability. And again, I want more decimal places than I'm given in the default view. So I'm going to drop down the probability value and I have 0.0165. Okay, let's go to the next part. In the next part, I want the probability that x is strictly greater than 18. So think carefully about how your probability is formulated. The probability that x is strictly greater than 18 does not include 18. It includes the outcome 19, 20, 21, and so on. So the lower boundary is going to be 19 because Desmos always gives you the probability in the binomial distribution that x is greater than or equal to some number. So the number that you fill in as your boundary in these probabilities is always included in the Desmos probability. Since it's a greater than probability, it's going to be a right-sided area. So the right region of the distribution starting at x equal 19 so that I'm not including x equal 18. And so again, it's going to show me that it's including 19, 20, 21, etc., etc. So my probability here is 0.9331. Make sure you round correctly here. The last probability is a less than probability. And again, it's giving me the probability statement x strictly less than 25, strictly less. So since it's less than, it's going to be a left-sided probability. And since it's strictly less than 25, that means the upper boundary of my region is x equal 24. So I want the probability x is less than or equal to 24. And when I drop that down, I get that that probability is 0.6586. Okay, just a couple of other things I want to mention here. First of all, if I want to, I can give my distribution a variable name. Just understand that you can only use that variable name once. I can't, if I name two of these with the same variable name, then I'm not going to be able to use that variable for anything because Desmos will say, hey, you've defined that twice. But one of the reasons I might want to give it a variable name is, for example, if I'm asked the expected value or mean of my distribution, there's formulas we can use for that. They're pretty simple for binomial, but I can also just use the Desmos built-in function for mean and also the built-in function for standard deviation. So I wasn't asked that here, but sometimes you will be asked that. And if you define the variable name, it's really easy to then just use those built-in functions. You can also use the built-in function, and instead of defining the distribution with a variable, you can just put the distribution definition into the built-in function, something like this. So that's okay too. You see, you get the same answer. It's really up to you and might depend on what else is included in the problem as to which of these is going to make more sense. All right, that's it for Desmos for binomial distributions.